Good morning. In the last video, we have seen the response of network elements, and in this video, we will solve simple problems on the response of network elements in AC circuits. So, I'll start with the first problem. You can see the problem highlighted in red. See, there is a 1000 watt heating element which is connected to a 250 volts AC supply voltage. And try to remember when I am solving the problems, when anybody mentions that it is a signal, it is mentioned like this, it defaultly is the RMS value. And I have shown you in the last week that if you want maximum value for a pure AC sinusoidal signal, you should multiply it with RMS. Okay. So, now, see, in this case, 250 volts AC signal, this might be the RMS value of the voltage. Calculate the impedance of the element when it is hot and the amount of current taken. When it is hot means when it is turned on. Now, there is nothing specifically mentioned here, but they have just mentioned as a heating element. So, normally which element dissipates energy in the form of heat? It is R. So, I will consider that. Considering the impedance to be purely resistive, to be pure resistance. Okay, this is the point which I am considering here. Now, what is the given supply voltage? Assuming a sinusoidal, 250 volts, and this is RMS value. Okay, and what is the power consumed? This is also given 1000 watts. Now, what is the current in the elements? Now, you do have two formulae. What is power? Power is equal to voltage into current. Or if I do V by I, I will get impedance. Right. So, the power is given as 1000, voltage is given as 250 RMS. So, if I want current, what I should do? P by V. If I do P by V, what I will get? 1000 by 250 and it is 4 amperes. Whereas the impedance, it is V by I. V is already there, 250 volts RMS. By current is also in RMS, 4 amperes. 250 by 4, it is 62.5 ohms. Right. And if you want to represent current equation or voltage equation, what is the voltage equation? Voltage they have given us 250, right? They haven't mentioned any frequency. So, Vm sin omega t, right? What is Vm? They have mentioned only RMS. If you want maximum value, what you should do? Root 2 into 250. So, I'll write it as 250 root 2. Sin omega. Omega they have not mentioned anything, so I'll keep it as omega and t. This is the representation of voltage. And for the current, it is representation of same Im. 4 into root 2 sin omega t. Understood? Impedance. It is only resistance, right? So, I will take it as 62.5 plus j 0. This is how you will be represented. Now, moving on to the next question. See, calculate the power which is being consumed by a 100 ohms resistive element connected across a 240 volt supply. See, they have already mentioned that it is R and it is connected across 240 volt supply. As there is only one component connected to the supply, the resistor, then VR is equal to Vs. So, which means the circuit will be like this. So, what is the supply voltage? It is 240 volts RMS. And what is the resistance? 100 ohms. So, what will be the current? See, V into I is power. V by I is impedance. They are giving you impedance and they are giving you, see, there is no other element. So, in this case, what is the total impedance? It is only R. Right. R plus, there is no reactance, right? 0. So, it is R only. What is the voltage? It is 240 volts. Okay. So, this is 240, this is 100. So, I can calculate I. How I can calculate? This is V by Z. So, it is 240 by 100, it is 2 point. So, if I want power, what I should do? Voltage into current. Voltage they have already given 240 and current I have obtained here 2.4. 576 watts. Simple things. Now, we'll move on to a little bit complex problem. What they are asking you. An AC circuit consists of a pure resistance of 100 volts. 10 ohms. And is connected to a AC supply. This is F. This is V RMS. What they are asking? They are asking currents. You know current how to calculate? I is equal to V by Z. What is V? 230. If there is any angle, you should write it. Normally for supply, we don't take any angle. What is the total impedance? R plus Jx. In this case, what is R? R is 10 plus J0. So it is again 230 by 10. So I will get 23 amperes. If I want power consumed is equal to P is equal to V into I. 230 into 23, it is 5260. Power consumed is V into I. And what they are asking us equations for voltage and current. If you want equations for voltage and current, see this is the general representation of voltage, sinusoidal. So for voltage, what I should write? Vm sin omega t. What is Vm? They have given only RMS value. So if I want maximum value, 230 into root. And what is omega? Omega is 2 pi f. They have mentioned frequency, right? So 2 pi into 50. What is the value of pi? It is 3.14. You calculate it, you will get somewhere around 314. And this is 230 into root 2, you calculate it, you will get somewhere around 325. So now you substitute here. What is the voltage signal now? V is equal to Vm sin omega t. What you will get? 325.25 into sin 314 t. Similarly, for the currents, what is the current magnitude? 23 you have got 23 into root 2, it is 32.525 sin 314 t. This is how you will be writing the expressions. Understood? Now we will move on to inductive and capacitive circuits. Now this is an inductance. See, a pure inductive coil allows a current of 10 amperes from 230 volts 50 Hz AC supply, which means the circuit is like this. This is V. How much? 230 volts 50 Hz. And this is the current flowing is 10 amperes. Find the inductance of the coil, power observed, and the equations for voltage and current. There is no resistance to observe the power, right? So power observed will be 0. It will absorb only energy, it stores energy in the form of magnetic field, okay? Now we will determine the inductance. For determining the inductance, first we should determine the impedance of the circuit. Only inductance is there. So R plus Jx, actually it is XL minus XC, right? There is no capacitive, there is no resistance. It is only JXL, right? So if I consider the magnitude, only it is XL. So I do have current and also voltage. So what is impedance? Voltage by current. It is 230 by 10. So it is 23 ohms. So 23 ohms is the magnitude of, the same is the magnitude of XL. Okay, so XL is equal to omega L. You know XL value, we have already done it. Omega L is equal to 2 pi f. You know the frequency, you substitute here. Now in this equation, if you want L, XL by 2 pi f. XL we have obtained 23 ohms by 2 pi f is 50 Hz. They have given it. We can get L value. Right. Now, if you want to determine the equations for voltage and current, how you will be writing? V is equal to Vm sin omega t. But here current, since there is a pure inductor, it is Im sin omega t minus pi by 2. I have told you in the last video. Vm, it is 230 into root 2. Omega, it is 314. Calculated because omega is equal to 2 pi f. You calculate it, you will substitute it here. Okay. And here also Im, that I current is given for you. It is RMS. For maximum value, you should go with 10 into root 2. 10 root 2 sine 314t minus pi by 2. This is how you should write the equations. Now, let us take another problem where a 400 millihenry coil, this is inductance, of negligible resistance is connected to an AC circuit, which has an effective current. Effective means RMS beta. RMS current of 6 milliamperes flowing. Find out the voltage across the coil if the frequency is 1000 Hertz. Only inductor is there. They have mentioned L is equal to 400 millihenry, which means it is 0.4 Henry. And they have mentioned current of 6 milliamperes. I is equal to 0.006 amperes. And they have given frequency also. It is 1000 Hertz. So what is the voltage they are asking? So first of all, what is voltage? Voltage is equal to I into how many impedances are there? Equivalent impedance. How many are there? Only one is there. No capacitance, no resistance, only one is there. I'll write J here, XL. If I want only magnitude of this, I into XL. All right. What is the magnitude of the current? It is 0.006. And what is XL? XL is omega L, right? XL is equal to omega L. Omega is 2 pi f, 2 pi f L. You substitute, F is given as 1000 Hertz, L is given as 0.4. You are getting 2512. So it is 2512. You substitute it, you will get 15.072, and this is RMS, not maximum value. Okay. And next, one more problem. Okay. Say here, a current of 250 milliamperes, this is I, RMS value, through a perfect inductor, which means only one inductor is there, and this is the supply, and the current flowing is 250 milliamperes. Then it is connected to 5 volts, 1 kilohertz supply, 5 volts, 1000 hertz. Determine the inductance. So we have done it previously. So what is impedance in the circuit? V by I. It is only R plus J XL minus XC, right? Nothing is present, only XL. I am considering only the magnitudes. V by I. This is V by I. V is 5, I is 0.25. I will get 20 ohms. And you know, when you do have XL, how to calculate L? Omega L is equal to XL. L is equal to XL by omega. Omega is nothing but 2 pi f. You substitute it, you will get value. Now, just last one problem using capacitance. Okay. Now, see here, this is capacitor, a 318 microfarad capacitor is connected across the supply. Find the capacitor reactance. The very similar way which we have done. The voltage is given for us. The capacitance. What is the capacitor reactance formula? Xc is equal to 1 by omega c. 1 by 2 pi fc. So if I substitute it, frequency is given as 50 Hertz. C is given as 318 microfarad. Substitute it, you will get 10 ohm. Right. Once you do have the capacitance, what is total impedance meter? R plus J XL minus X. No inductance, no resistance, only capacitance is there. I will consider only the magnitudes. It is X. So if I want I, this is V by Z. I is equal to V by Z, right? In Z I do have only XC. V is 230 RMS. XC is 10. So I will get 23 amperes RMS value. And they are also asked RMS value of current, I have obtained 23. And they are also asking equations for voltage and currents, right? V is same, Vm sin omega t. They have given 230, so I will take it as 230 root 2 into sine. Omega is, frequency is 50, right? Omega is 2 pi f. 2 into 3.14 into 50. I will get somewhere around 340. So this is 314T. Whereas Im is nothing but root 2 into the value which I have obtained. It is 32.53 it seems. Sine 314T, omega is 314 plus pi by 2 because it is a capacitance. Okay, so I hope you have understood now. Okay, see the conclusion. Impedance plays a very crucial role in AC circuit analysis. And the impedance offered by the resistance, inductance and capacitance, it varies. For resistance, it is not dependent on frequency, whereas for case of inductance and capacitance, it is dependent on the frequency. An impedance consists of two components, resistance and reactance, and it is always measured in ohms. Okay, so practice the problems at home. I hope that now you are able to determine the impedance of given network elements and also determine the response in them. And these are the lecture level problems. Try to practice them at home and come back for tomorrow's class. Thank you.